Welcome back. I want to explain something to you before we move to MOSFETs and to relay. This is the circuit that we used in our previous simulation. So when we power it, be it through a full divider using LDR or some other components or some other sensors like thermistor, or manually like this, when we power it, when we switch it on, the LED will come up. That means when we switch it on, the current will start moving through the circuit. So this is a direct use of transistor. We also have something called inverter. Inverter is when the opposite of the input, when the opposite of the input is the output. Know now that we assume, according to logic, 0 volt equals to 0, and 5 volts for TTL equals to 1, right? So when this equals to 0, it's 0 because there is no voltage applied there, right? So the output is 1. When the input is 0, the output is 1, right? And when the input is 1, the output is 0. So instead of, this one, when you press it, the LED will come up. But with this configuration, when you press this one, it will go off, and when you press it, it will come on. It will come up. So that's how inverter works. This is the configuration. This is a pull-up resistor. You connect a resistor to the positive terminal of the battery and the emitter to the negative. So between the collector and the pull-up resistor, you will take your output. So that output will be an inverter, will be an inverting form or inverted form of the input. So assuming this circuit, this circuit now that we use in our previous video, this circuit works like at night. The LED will come up, right? And at night, during the day, the LED will go off, right? So if you want to reverse it, so instead of connecting instead of connecting it like this, so you can reverse it back. I actually made the mistake in this circuit. There's a mistake there. So instead of connecting the emitter directly to the ground and putting this one between this, I connected it in the wrong way. So let me quickly correct that. Okay, I've corrected it. So if you compare it with this, see down, they are now the same. So the LED is connected to the positive, most always, and the cathode of the LED is connected to the collector. So, and for this also, the buzzer is connected to the positive and the other side connected to the collector. It's not that after the collector you beat the buzzer. Hope you are getting it. So the first one was wrong. So you see now, you are seeing a sign that the buzzer is working. So that's how inverter works. If you want to invert it now, that you want it to be sanding, to be giving sand during the day. This one will be working during the night. You want it to be working during the day, so you will need to use an inverter, something like this. So instead of connecting it like this, so you need to change the configuration of the transistor. So this is where you put it actually. So the output from this point will be fed in to the base of this transistor, and the output of this transistor will be used to switch this one. Hope you are getting it. So let me draw it for you. So now during the day the circuit the diagram is working, the device is working, and during the night it's no more working. So it's the reverse form of the first one that we used. So I just used instead of connecting this to this as I did the other time, so I just put an inverter circuit there. These circuits, I put it there. So I connected the output to the base. So I actually supposed to put a resistor here, but there's no problem, it will work. So I connected the output to the base. So and from the base, the output from here, so the output from here is what is inverting. So if you have 1, it will be 0, right? So you already know that during the day this output will be 0. I want to invert it to 1, so we need to pass it through an inverter. So at this the circuit of the inverter is complete with this. So positive to this as we did here. So positive to this, right? So from between the positive and the collector, we take out another voltage to control the LED, to switch on the LED. So in this in this case, for this big circuit, we use the output to switch the transistor. So when we have 0 here, we have 1. When we have 1, we have 0, right? So when we connect this to the transistor to invert the circuit, invert the output, so the output that comes out, which is the inverse of what is in this point, so the output will then be used to switch this transistor. Hope you are getting it. So that means at night the LED, the buzzer won't come up, and during the day the buzzer will come up. So now you can change this to a thermistor. You can change it to a thermistor instead of using LDR. Use a thermistor to detect temperature and some other things.